Thanks, Scott. It's really great to be, well, it's really great not to be on Zoom. I think that's the short answer. So my presentation today seems a bit odd because we are talking about the skin of buildings, and what I'd like to look at it a little bit differently, picking up also on what Lars was saying earlier, which is about integration. To look at the skin and the design of the skin of buildings, but from a much more holistic perspective. And the notion that beauty should be more than skin deep is something that I think many of us intuitively understand that. And really, a chance for us during this COVID crisis to look at our work a bit deeper, not the slapdash, rush it out approach, but rather a more deliberate, thoughtful, stop and think about what we're doing, and also why are we doing it. And for me personally, as challenging as the last couple of years have been, it's been a chance for me and my team of architects and engineers at NOR to really slow down and ask ourselves, what's the deeper purpose of what we're trying to achieve? And certainly, facade is part of it, but it's just a part of it. And the thesis today is really about what you can see versus what you can't see. The visible versus the hidden. The complexity versus the simplicity that we all strive for in our work and in our lives. And this dialectic between the complex and the simple, the aesthetic versus the function, I would argue that it actually is a very interesting question that we all confront in our own lives, one way or the other. So it's not just about how it looks, it's about how it works. How does facade and design of buildings, how does it really work in the aggregate? And nature is a very hard act to follow, because when you look at our work, it looks quite mundane compared to examples of design in nature, which are spectacular, mysterious, and in many ways, we're just beginning to understand how some of those things work. Lars showed us an example of a variable facade where the metal changes shape based on temperature change. And plants do that, right? Plants follow sunlight. And we're still trying to figure out what is the mechanism that allows a plant to change direction and follow the sun. And the fact is, with our greater appreciation for the uniqueness of the blue marble that we all sit on right now, we have as a design industry, we have a responsibility to look at our work and to ask ourselves, is this really the best we can do? And I'm not convinced. I think certainly in the post-industrial world, we are all guilty in one way or another for a rather consumption-based approach to our work and to how we place ourselves in society. And once in a while, we get a chance to ask, can we do better? And I'm in the building industry, right? I mean, I design buildings, some of them get built, and the question is, what kind of report card do I get? How well am I doing in that process? And this sense of responsibility which we talk about, the intersection of a number of concerns, is super, super critical. A couple of years ago, we had an interesting opportunity to take on a new project in the Dubai Marina. And I'm going to take you through that project. But really, when I present it, I hope you'll remember the earlier images I showed you, which were not about buildings. It's actually more about our approach or our aspiration. And I have to say, I'm not convinced that I'm succeeding at the level I'd like to, but I am walking the path. I'm willing to try it. And the process for anyone in our industry, we have to be brave enough to try new things, to embrace innovation, to be willing to fall down and stand up again. There is a Japanese saying that I like, that I've been thinking about, Nana Kurobi Yaoki. Fall down 7 times, stand up 8. So that kind of grit, the ability to take a hit, to try something, and then to say it's not good enough, to try it again. I think that's what makes it all worthwhile. And we had an opportunity among many, but the one I'm showcasing today is a pretty interesting opportunity to take some risks, probably fall down on a few of them, stand up, keep going. And when we looked at this property for our client, the first group, what was exciting was that we have a client who believes in us and is willing to take some of those risks with us. And also, I'm extremely lucky to have a team, a super talented team of architects and engineers, interior designers, and consultants who work with us to allow us to explore these risks and to see what we can do. So in the very beginning of the project, what we said to our client and what we recognized was that there was a unique opportunity here, but also a very difficult project, because the property itself is a residual triangular space on the edge of the Dubai Marina. And the challenge here for us was actually, the mandate was not to design the tallest hotel in the world. The mandate was to design a hotel. And when we started to look at this property, a previous consultant had already developed a design for a residential tower, in this case, a 60-story residential tower. The piles were already in the ground. And then, of course, the Great Wall Street crash happened. So when we inherited this property, there were already piles in the ground for a building that was supposed to look something like that. And as we started to look at it, we asked ourselves, well, what can we do? What are the possibilities? And we spent probably a month going through a process of shape optimization, exploring geometry, and the notion of bringing landscape into the project, which is something that we are exploring on many of our projects, where we are looking for a vertical urbanism that brings into that verticality some of the aspects of nature that we all crave. And as I said, we didn't start by trying to be the tallest. In many ways, that was just the byproduct of a design process. And the design process we use combines everything. It combines digital, 3D printing, but it also has a huge amount of exploratory sketching and model making. And for us, that's really important. The translation of the idea, which is cerebral, and how do you start to take that idea and how do you test it? And you have to be brave enough to test it on paper. You have to accept the fact that your tests, many of them are abortive, but you just keep going. And as we test these ideas, we are also building models, both physical and computational. And we are working with architects and engineers simultaneously. Our process of design is not exclusive to one discipline. All the disciplines are involved simultaneously. And I really believe that's very important. It's really important to design in a collaborative environment which has many voices, because that's when the unusual solutions could reveal themselves. These are just some pictures of our lab in Dubai. Our office is in Festival City, Festival Tower, and we have a 3D lab within our office, and we are building models. We probably throw away 98% of everything we do. We're extremely inefficient as a company. And that inefficiency in our design process, which is extremely iterative. So we're constantly testing ideas, both sketch and model form. We're asking ourselves, does it work? Is it awkward? We're looking at costs, by the way. Yes, the building is iconic, but actually it's on budget, and the budget was pretty tight. So that there's a tremendous process of a lot of smart people with lots of different perspectives all coming around the table. And I think Lars touched on that on his very focused presentation on Façades. In the end, it's about the HVAC system and how the cooling works, right? And it's about how much lease space you're going to lose when you go to a double skin versus the solution you showed. So you're thinking, as I think many of us are, you're thinking multidisciplinary. And we do that. We're exploring ideas and testing them, communicating them to our client. We're also testing them for cost and efficiency. We're testing them for engineering. And this process, in some ways, is a bit like nature. I mean, I imagine that when a forest grows and new trees appear, they find a way. It's a process of trying stuff, studying it, being brave enough to throw away 98% of what you do. So you can fall in love with your work, but you shouldn't. You should be able to walk away from it. You know? And these are some photos of the site. These were taken about 6 months ago, and this was last week actually. So you can see that the podium is up to level 8 now. That's 8 out of 82. It's an 82-story tower. But what's really interesting about this building is not just the fact that it's an iconic tower, it's its location. So we've lifted the podium up, and this will all be glass. This is going to be a glass facade with the public realm. You can actually walk up the marina and go right into the hotel. So we lifted the hotel up to allow that to happen. Now I have to talk about facade a bit, because it would be embarrassing if I didn't. So we did use parametric modeling. One of the challenges for us really was that the building shape, no two floors are the same. So we have 82 unique flow plates in this tower because of the shaping of the tower. And that actually was a unique challenge for us. And we used Grasshopper and Dynamo and other software that links to Revit to optimize the panelization. And in fact, we work with Scott's group at AESG, and that was really, really great. And we found a way to clad this tower in a highly reflective, silver reflective, high performance glass, which is cold bent. So that the glass is actually made as rectangular panels, actually slightly trapezoidal panels, but they're flat. And then they're cold bent at application. So 3 points are fine, and then the 4th point, the contractor pushes it or pulls it to achieve the warped surface. And you can see the flow plate types. I mean, that was interesting. We couldn't have done that if we didn't use three-dimensional software. Our 3D software, which you're all using, Revit, we produced all our drawings from that through modeling. And what's exciting in a city known for its stars, I think we're going to have a chance to add something. Yes, it's tall, but I think what will really make it unique is the gardens. There are 12 landscape gardens which are naturally ventilated. This building actually breathes, and I'll show you the glass louvers. They're computer-controlled glass louvers which allow natural air into the building, into the gardens. We've designed the interiors, the architecture, the structural, mechanical, electrical engineering is all done by our group in Dubai. And we are striving for that simplicity. Our goal is to find something that's elegant, simple, something that over time will still look interesting and exciting. I call it the eye of the needle. At the very top of the tower, we have a steel structure that takes people, we're imagining school children will go up to the observation deck. That's an observation deck at level 82, which will be open to the public. And it will allow for education, it will allow students and others to actually go up the tower. I have 8 minutes left, so I'm going to think about how best to use that. Yeah? So I'm going to go relatively quickly. In terms of construction, we've been looking very carefully at how it's built. And so it's a jump form concrete core that's moving actually pretty much ahead of schedule right now, with 3 outrigger floors. And these outrigger floors are also concrete, which are also the MEP floors for the project. And the outriggers are where we bring the gravitational load is brought back to the core. And as we were thinking about this project, we realized early on that one of the challenges for us was that the piles in the ground were designed for a rectangular building with a rectangular core. And our proposal is a circular building. And I've always had this problem, how to put a circular peg in a square hole. I mean, I think many children struggle with that, and so have we. But we found a way, and you can only do this if you look at it as an integrated design exercise. We found a way very early through the introduction of micropiles, which are sleeved through the existing piles, and then captured in a raft that allows us to build a tower of the shape we want. We worked with some really amazing soil engineers, and we of course looked very carefully at wind. There's a strong incoming breeze that comes in over the Gulf, and the fact is that super tall buildings, especially, the structural design is dictated by wind forces, not by seismic. Seismic becomes less important and wind becomes the primary factor. And so very early, in the early months of the project, we hired a firm to do computational fluid analysis for us. This is CFD, computational fluid dynamic analysis, to really look at how the incoming breeze interfaces with different shapes of the tower. And it was quite interesting. We found through a process that we were able to reduce the moment forces and the lateral forces on the tower by up to 40% by shaping it right. And part of that shaping was the taper. The famous tapering and the shape of this building also helps to confuse the wind, they call it. So super tall buildings, what you want to do is you don't want them to be extruded, you want to change the geometry. and that reduces the vortex forming on the leeward side of the building. And the vortices are the main issue, which you saw a graphic of that in the CFD. So the shaping of this star had a lot to do with our computational analysis that came from scientists, and we worked with them, and we tested probably a dozen shapes before we settled on this one. And then the very top of the towers, of course, is very exciting. We wanted to go higher, but we introduced a hole that allows the wind to go through. And we found that that had also a very significant effect on the lateral forces. Now, the atrium gardens are a really exciting part of this project. There's 12 of them, these gardens. And these gardens are for the use of the hotel and the guests. We are still programming them. We're trying to decide which garden does what. So there's going to be real use in these. But when we looked at them early, one of the things I felt is that we should not air condition them. We shouldn't be spending so much cost. We should find a way to use natural air, especially 6, 7, 8 months of the year. So our own MEP team has done a lot of analysis, and what we've found is that by cooling only where people are and letting the temperature gradient go up in the space, because people are not up there, people are down here. There's some panoramic elevators in the back, but they're air conditioned. We're able to generate and to create a natural environment in a super tall building as 12 stacked gardens. And what I find very exciting is that we've done some detailed analysis of the air conditioning cost of this tower, and we've compared it to the ASHRAE base case. The ASHRAE base case is about 14.1 megawatts of cooling, and this tower is 25% below the base case. So it's a glass tower, it's got gardens in it, and yet it beats the ASHRAE base case by at least 25%. So the question is always in my mind, can we do exceptional work and be responsible at the same time? Can we do both? And I think we can. I think we all can. I think the secret is to be open to a multidisciplinary approach to design, where you are simultaneously, you have engineers, architects, interior designers, facade designers, landscape designers, you have security guys, you have elevator people working with you, environmental design. You do it all at the same time. You don't do it in sequence, you do it in parallel. And if you are brave enough to do that, because it's scary to design that way, because it gets really messy, and it can create a lot of anxiety. Like the team can feel that there's too much input, there's too many different opinions. So I'm the conductor of the opera. That's my job. So I hold the conductor stick, and then I've got these really talented people to work with, and we are able to do once in a while, we're able to push the boundaries of what we do. Not every time. It really comes down to the project and to the opportunity. Sometimes you get lucky. And I'm almost out of time. I've got a minute left, so I want to just say a few things. I'm going to keep scrolling, and I'll just say a few things about our approach to design. It actually goes beyond whether it's Ciel or whether it's some other project. We do believe that beauty should be more than skin deep. Certainly, I believe that true beauty or striving for perfection, because if beauty is about perfection, and perfection is actually unachievable, I don't think we can ever achieve it. But we have to try. And that's super important. It's important to challenge convention, and to embrace invention in our lives. It's important that we accept the natural into the artificial. Embed it into your work. It's important to celebrate the visible, but also the invisible. Everything is not how it looks. So if you have the time and if you have the patience, find time to go deeper into your own work, deeper into the work of others, because that process of going deeper and taking your time, they call it, it's a patient search. A patient search. And it's tremendously rewarding if you've got the time. Thank you very much. Thanks.